be interested to speak with each of you towards the end of the presentation. This is going to be in three parts. I'm going to talk about the business conditions for the construction industry today. I think we tend to think about the economy as it was in years past rather than the new economy in the way that we think about delivering projects. And for construction, I think that old economy is a developer has a piece of land, engages an architect to see what could be done with the land. Permitting people say we can approve something different that gives you value, and then a contractor's engaged. But that serial process is changing, and the types of use are changing. And you can even see it from the ballot initiatives in California recently about changes that I think impact both the sharing economy and the real estate economy in general. I'm going to cover briefly what I call legacy challenges, things that have created inefficiencies for us in the industry. I'll probably go through that section pretty quickly because I think everybody on this call should be pretty familiar with those, but I just want to make sure we're on the same page in terms of what those topics are. And then the third part I want to discuss is really how design for manufacturing and assembly and a modular off-site construction process can help reduce waste. So those are the three parts. Before I start, though, I like to point to a historical perspective. Some of the ideas that I'm talking about, they're not brand new. They're not a year old. They've been around for 20, 30 years in some cases. When I was in San Francisco working on high-rise projects for Trammell Crow in the early 90s, they said to me, just leave the elevators out of your documents. Just put a bubble in your drawing saying provided by others. And likewise with the contractor that was a PCL, they said, you know, just this will be provided by others, just leave it out of your contract. We're going to buy elevators from Otis for 5 projects that we're doing in the region over a 2-year period. They were getting a 20 or 30% discount from the elevator provider by going direct and cutting out the contractors and the A&Es in that process. So this is not a new thing. This is an article from about 7 years ago from The Economist, and it says that 2/3 of the, they call them lifts in the UK, but elevator market is controlled by just a few firms. Most of these are actually our customers, so we know them fairly well. So we have an inside view and certainly can corroborate what the Economist article is saying. The margins for these elevator companies is 25 to 35% for the maintenance and operation phase, which goes 30 to 50 years sometimes. But when they manufacture an elevator and install an elevator, they're actually making probably an 8 to 10% margin. So what this tells you is that these elevator companies want to be primarily in the operations business, and the construction business is a necessary evil for them to be in the more profitable operations business. So this is true of many building systems, but elevators has been a leader in this change. The other thing that's important is that the maintenance and operation revenues are steady year over year based on how big your portfolio is. Whereas the revenue from construction work is cyclical. Every 9 or 10 years, you know, the bottom falls out of the market, projects stop, and the manufacturing business, with its poor profit margin, also has poor revenue overall. So because of stability of revenue, attracting stock market investment, and for increasing services revenue that can be created, this is one example that's been around a long time of what I'm going to talk about in a minute as the sharing economy. Before I talk about it directly in construction, I'm going to talk about it in some other industries. So let's start with car sharing, which is the recent ballot initiative in California. So we've got Uber and we've got Lyft, and as one model that everybody knows. You probably also know Zipcar and FlexCar. With Zipcar, there's a garage near your home and you have the right to use cars and you reserve them by a calendar, the advantage is you get the vehicle you need when you need it. If you need a van to take a group of friends someplace, you can take that. If you need a truck to move something, you take that. If you just need a small electric vehicle, you take that. You take what you need when you need it, and you're sharing a group of vehicles with other people. Get around is the opposite of that. And this is a very American sort of thing where a family will have sometimes 4 cars or 5 cars. They've got more than they need. So they can park 1 or 2 of those cars on a street somewhere, and Get Around will come and put gasoline in it, maintain the car, wash the car. It's sort of like Airbnb on wheels. So now you're able to get monthly revenue for your extra vehicles. Whatever the sharing model is, the trend is pretty clear that the idea of owning a car and paying for it all up front is going away. We moved from owning to leasing, and now we're moving from leasing to sharing. If everybody in the US right now were to be using a car share type of service, we would take 60 to 70% of the vehicles off the road. This would be a big change in our ability to impact the environment. So it's a trend that's happening. It's happening more quickly in California than other places, but I see it all around the world. You know, I'm in Paris and I see these electric scooters. I'm in London and I see racks of bikes and little electric vehicles that can be shared. So it's not just a U.S. phenomenon; it's a global phenomenon, and it's a sharing approach to things. As we move from transportation and car sharing to the housing market, we see Airbnb, despite their current struggles in this year with the pandemic, in 2019, they started thinking about designing their own backyard units, these accessory dwelling units. This would give a consistent brand and experience for people who wanted to take Airbnb space. And it positions them even more strongly against traditional hotels where you know what to expect. You know the quality of the room, you know the quality of the experience. When you're using Airbnb and it's a house or an apartment, it's a very different experience, and you have to kind of scroll through the ratings and look through the photographs to understand what you're going to get. But I think Airbnb is tightening up their brand by actually thinking about creating a product. Who would have thought that a co-living, sharing type of company would become a serious competitor to major hotel chains? But with the pandemic, there's kind of a question of who do you trust, a big hotel company or an Airbnb company? I don't think we have the answer, but this trend is, I think, going to continue to grow. It will not go backwards. If we look at another model, Ollie is based in Boston and New York right now. I think they might be in Miami or a couple other cities soon. And the Collective in London. These are not vacation rentals like Airbnb. These are permanent living situations, but they're not like your traditional apartment. With Ollie, the proposition is that a group of friends have graduated university together. They've all agreed they want to move to Boston, New York, or some city. And they've decided that they're going to share a flat there. But what they're actually renting individually is a bedroom and a bathroom. The rest is being shared by an agreement between the 3 or 4 flatmates. If you want to have a full kitchen, you can do that and go grocery shopping, or you could have groceries delivered. Or you could use the dining hall in the facility most of the time and just have a small kitchenette. So it reduces the cost of the kitchen component. You could have your own laundry in your unit, or you could use the laundry service in the building. So there's many, many options about how you would configure your unit. These are new and all those configurations aren't available, but I'm seeing a number of companies like this that have variability. Likewise, you could share a car or pay for a parking space. So many alternatives in your lifestyle, but it's targeted at younger people, single people, people without children. Collective is a little different than Ollie. uh, the idea with collective is it's not renting a room in one place. It's renting across multiple locations. So if you're going from Paris to London to Amsterdam, you get to say where you're going to be, and all of your services go with you. If they know you want certain kind of laundry service, certain kind of meal service, certain kind of car sharing service, that goes with you. The advantage then is now that's something you're doing instead of a hotel, so you can charge it in your expense report. So now your cost of living goes down substantially. And the idea of business travel is different in that it's like some aspects of your home are following you to these places. But this kind of trend that services are actually more important than the asset or facility is, is the point that I'm trying to make. As we move to co-work, WeWork, despite their financial troubles, something like WeWork will be back. The idea of a shared workspace that you can kind of configure to your needs and adjust over time. And the ability of WeWork to understand differences in different geographies. When I go to a WeWork in Atlanta, I see that certain kinds of items are available on the menu. The break room is a certain size. The conference rooms are a certain size. When I go to London, it's actually quite different that the whole break room is different. The size of the meeting rooms and the size of office is different. When I go to New York, it's different yet again. So WeWork is understanding different preferences in different geographies. Similarly, if you think about what Google is doing with their Nest devices, thermostats and doorbells and cameras and these kinds of things, they're interested in collecting data in the real world to complement data that they have online. And I think that's how what Google is doing and what Amazon is doing is similar to what WeWork is doing. In this case, the data is more important than the asset. Amazon and Google will give you a device practically for free for like $5 or $10 that can control devices in your house because they're interested in the information associated with the device more than the device itself. So now we have a hierarchy where the data has a very high value, services has a perhaps equally high value, and suddenly the asset has a lower value compared to services and data. This is the implication of these new economies. So if we translate that from just a new economy in general, and we start thinking about smart appliances and what's happening there, we see, a Samsung refrigerator, for example. It's got a camera inside. It synchronizes it with your phone. You're able to, keep your grocery list on the front of the refrigerator like a whiteboard. You're able to see if you're going to prepare a certain menu, if you've got what you need. Some of these will barcode scan or weigh when things go in. Some rely on cameras inside, but there are variations about collecting information about your appliance and the relationship of your information in your appliance to your phone or portable device. When my family went to the Amazon Go store in Seattle, they walk in with their phones. It recognizes their Amazon account. They can pick up things off the shelf and it knows when you're picking it up or putting it back. It sees your behavior. It's just like going to the Amazon website. It can see what you put in your basket to check out and what you decide to return and not purchase. That data is very important to them. Time of day, type of purchase, time of year, those shopping behavior habits are very important. And they want to sort of be in the background observing that in the real world in the same way they do in the virtual world. And now you open your app and you say, I think I'm ready to check out. And it says, oh, if you're going to make that particular recipe, this is what you need and this is what shelf it's on. And then you say, oh, wait a minute, do I have enough milk? And you turn the camera on in your refrigerator remotely and you can see you actually need to buy some milk. So this kind of relationship between an appliance at home, your mobile device, and a new type of shopping experience is really changing what we would create for a retail physical asset in the world. Um, this is a customer of ours, Miele, that does washing machines. They do sort of a steam cleaning and washing and drying built into a single unit. And they too have sort of an app interface to them. But the data is going back and forth to the factory as the machine's being used. So they understand when certain maintenance has to happen. They understand preferences. They begin to redesign the product over time based on users' behavior. But a, an appliance capturing preferences and knowledge is kind of like what we talked about with Google, that the data associated with the appliance or asset is more valuable than the asset itself. So let's translate from appliances to thinking of buildings as a series of appliances, that certain components in a building can be assembled together and provided as a product that can be upgraded over time, unplugged and plugged back in. It can have a remote operating system upgrade. It can have a lot of upgrades over time. I think of this a little bit like computers from the late 80s and early 90s, where you bought a basic unit, but then you maybe increased RAM, you got a better graphics card, you decided you wanted a more ergonomic keyboard and mouse, but you had the same base unit, but you began to upgrade components over time. So imagine this utility closet. This one's a European model, so it emphasizes instant hot water heating over the U.S. electric type of system. And it's using it for radiant heat on the floor, not just the domestic hot water. But there's that same washing machine as an appliance that's part of this sort of collection that's being provided. And then there's a smart electrical panel, and it's observing how power is used in a unit over time. So imagine this in a high-rise apartment building, and you've got multiple units, and you're beginning to see preferences for behavior, that more gas is being used to heat, more water for radiant heating during the winter, and these changes in preferences over time. You're seeing daytime use of electricity, and suddenly it justifies putting more solar panels on the roof, because you actually don't need batteries to store it, because it's daytime use of power, not battery stored nighttime use of power. So these are the sorts of upgrades that you can make over time by being able to observe patterns of use in a building. You could think of a bathroom pod in the same way, and think of someone who maybe lives in the same place for 20 years, and they've just finished college, and initially they just want a small, efficient bathroom with a shower. And then they get married, and maybe they want to have the toilet area separated, and they want to have two sinks. Well, that's an upgrade to a new module. And then they have kids, and they decide the shower doesn't work. They want to add a bathtub so they can give a baby a bath in the bathtub. And then they get older, and they're going to retire in the same place eventually, and they want grab bars and handicapped accessibility in the bathroom. So instead of bringing in a construction crew every time and demolishing things and restoring it piece by piece, these are modules, and you actually don't pay for the module up front. You're paying a monthly subscription. It's like leasing an automobile. The right module gets plugged into your home when you need it, and it has a bunch of features that get upgraded over time, and you can decide when you want the newest module. So think of a bathroom as the new iPhone. It's something that you can skip a couple of versions of, but then this is a really nice version that comes out, and you want those features. So let's go from thinking of buildings as appliances and what I called the sharing economy, which is, I think, is a pretty common term, to something I've coined as the distanced economy. And that's this year, and it's the pandemic. And I've made up this term because I think it implies two things. One is that we are actually accelerating some aspects of the sharing economy, but we're also changing behaviors in ways that the things I talked about earlier can really improve. So these are just three examples, but for someone that was considered moving into a senior living facility a year ago, that would have been straightforward. Right now, I'm not sure some older people are quite ready to go into these retirement facilities if COVID spread is so much faster there than elsewhere. Likewise, a lot of people don't want to go to the hospital for routine checkups because they're afraid they'll go in and they'll come back out and they'll be sick when they come out when they were healthy when they went in. Many of us are telecommuting, and that trend continues, but the expectations about the quality of the experience have changed. The sound quality, the video quality, other things are changing. And with learning, as schools close and kids are expected to do distance learning, we can compare what happens in the gaming world with VR and what happens in the quality of sort of Hollywood experiences to what we're doing in schools. And it's really sort of an embarrassing gap that the quality of online education is just generations behind a gaming experience or any sort of entertainment experience. I think we do see a few examples that are pretty good. I think Gates Foundation has created this thing called Big History that's pretty good graphically, but I think we still fall short on interactivity and new roles for teaching and how teachers work in this environment. So just in this past year, we've seen a need for these three things as a minimum to be very different than they have historically. So responses might be that we would have accessory dwelling units in a backyard to accommodate us locally, or these pods that are like ADUs might be aggregated together to create mini campuses. You know, Google, for example, has said they're going to wait till June of next year to require people to go back to work. So what happens when Google says you can work from anywhere in the world as long as you have a quality connection? And what happens when a group of employees in a certain geography say, we'd like to get together in a mini campus? So this is, I think, some possible corporate subsidy for ADUs or mini campuses, a market that was, I think, driven only by the need for extra housing now could be driven by making senior living and healthcare access more local. Combination of wearable devices with the environment itself, the slightly different needs for different kinds of office modules. Are you in engineering and manufacturing? You might need something different than somebody working in finance or banking. And then learning modules. I think that, in my family, we decided to homeschool about 2 years ago. Well, it's turned out to be good for my daughter because now all of her friends are being homeschooled and she doesn't feel that it's different. But the first thing we noticed in homeschooling was these pods forming where you would get together with other families. And so if you needed to cover science topics or specialty topics, we would do that as a group. And then the math and reading we could do ourselves directly. We happen to have a special needs for that, but I think with the pandemic, there's a different need where you want to find a group of people who have the same attitude that you do about whether you should wear a mask and what social distancing means and what all these things mean. If you have your own group that agrees with these sorts of rules, then you feel safe having a small group come together for a learning experience. That's a different type of situation than we've had historically. It implies that we'll need new products in construction, but we'll have to have a new mentality about how we build them and what the real purpose of them is over time. So that's really talking about economies, and I've probably taken a little too much time there. Sustainable design I'll go through quickly. I think we all know that green building has been important, sustainable design has been important because 70% of electricity is coming from buildings, for example. But we are currently wasting at least 30% of an owner's budget in the construction process. And I don't think we can call ourselves green and sustainable if we're wasting that much in the delivery process. Also, I think there's a big difference between the understanding of lean in manufacturing than there is in construction. This is a survey we did about 7 years ago with McGraw-Hill. It's still available if you want to look up this Lean Construction Smart Market Report. It's a free PDF you can download. To net it out, we asked about 150 general contractors and subcontractors in the U.S. about their lean practices. And we had different reporting on different levels, but the way I netted out is that only about 8 or 10% of U.S. contractors used any real lean practice that resembled manufacturing at all. So the consequence of that is also in this survey, we asked the lean practitioners what they thought about construction efficiency. And they said it was horrible. They said it was highly inefficient. 62% of them. Two-thirds of them said construction is highly inefficient. And that tracks with Paul Teicholt's SciFi chart from, that tracks construction over the past 60 years or so, that even agriculture outperforms construction now in efficiency and productivity. And here's another quote from the economist that 30% waste in U.S. construction industry. But then if you turn around and ask the non-lean practitioners, 55% of them say that the industry is highly efficient. So that's quite a contrast to see that 90% of the market is not using lean practices, and most of them, more than half of them, think that they're really efficient. So there's obviously some gap in there that shows a truth that we're not all on the same page about right now. So let me move from the sustainable side to other legacy challenges. Again, I'm going to go through this part quickly because I think it's familiar to everyone on the call. First, there's the problem of redundancy in the way that we work. And I'm just going to break into these three silos initially and talk about architects using BIM tools to create essentially permanent drawings, while as manufacturers are using other kinds of tools like Tekla or some shop drawing fabrication documentation tool. Their skill set's different, the software is different. And then the builder has got yet another tool for 4D or for sequencing. These three tools don't exchange information very well. It's import and export. It's not a two-way data integration. IFC is not really going to fix it. It's very problematic. But imagine we had integrated drawings from these sources. Imagine we had integrated models. Then we want to connect them to cost information and schedule information. If we could do that, we could actually create a production control system that would eliminate a substantial portion of that 30% waste. This is the same idea again, but I like this. I've been using this for about 15 years now. This is an architect's view of a column. It's the cladding on the outside, and it's the clearances required by code. This is the consulting engineer's model, and it's just showing the size of a concrete column or a beam. Then there's the structural detailer. They have the rebar inside the concrete that the engineer is not showing. And then there's a builder deciding I'm going to use wood formwork or metal formwork, and how am I going to set it up and make those connections, and how am I going to reuse it? And then there's the facility manager who wants to see everything together, so that if they get ready to core drill a concrete floor and it's a post-tension slab, they have confidence they're not going to hit one of those cables and it's not going to explode. So those are 5 different versions of a model. So let's say this is the, let's use the Apple Computer Campus as an example. Here's the architect, Norman Foster, and they're working in MicroStation. And here's the engineer, and that's Arup, and they're using Revit structures. And here's the structural detailer at Clark Pacific, and they're using Tekla. And here's the builder, which is DPR and Skanska, and they're using Navisworks. And here's Apple as a facilities manager, and they're using an Archibus or something else. But there's 5 different professionals with 5 different software packages, and they're trying to work together. IFC doesn't fix it, and the current import-export system, I think, is very problematic. Next problem is on-site congestion, and I think we understand that as well, that we first have the structure put up, and then we're going to put in the slope piping for the plumbing, then we're going to put in the big MEP components, and then we're going to run the electrical systems, and then we're going to move up to the next floor and do it all over again. But as the trades move through, we end up with a problem of sizing of the trades and the sequencing of the trades and the stored materials the trades want to use, having it at the right location. If we were able to do that in a prefabrication in a factory, it might be better to get the trades off site, but how big is the module and how is it handled and how is it transported? Is it a faraway factory or is it near the job site? Is it a panelized system? There's a lot of factors. And then how do you manage the on-site installation? If, from what I said at the beginning, that the service in the life cycle is more valuable than the construction, we're missing opportunities in the way that we create those modular elements. We're putting them together in a way that solves the problem of shipping and installation, but it does not solve the problem of how do we disassemble or reuse and how do we upgrade over time. So that's sort of a problem I see on the job site and delivery portion. If we compare manufacturing and construction, these might be drastic. I think this is probably one of our customers like Tesla, which is highly automated. And this is not an unusual job site with a lot of hand tying of rebar going on in the field. You can see the challenge just right there in the quality control and efficiencies. On the left, we have a typical issue on a job site where until the excavator gets out of this corner, we can't start using these stored materials on site. So there's a certain amount that has to be done on site no matter what. The excavation, the pilings, the foundations, the sheeting and shoring, the tiebacks. There's a bunch of stuff that has to be done on the job site. And we have to deal with the on-site congestion. Also the installation of modules if you do off-site. But here by comparison is a factory setting, and you can see the workers in blue leaning over equipment and underneath the machine that's depositing the concrete. That white carousel in the upper right is equivalent to probably 3 truckloads of concrete. So it's a high-speed carousel moving around the factory, and it's connecting itself to this yellow thing with a gantry on it. That's kind of a 3D printer that's laying out the concrete on top of the rebar that's been produced by another machine in another station. So this is the product they're making. It's exposed rebar on the top. It's a finished concrete on the bottom, and they're using it as a combination of formwork to rapidly create the floors and ceilings on a project site. This is what I like to think about as a difference between off-site construction and off-site manufacturing. I talk to a lot of construction companies and I say, do you have a factory? And they say, yes. And I go and visit and I see this image on the right. This is workers indoors. It's a good idea. It's helpful. I mean, they're not wearing hard hats. They're not wearing winter jackets. The lighting is good. They can work 2 shifts. They can work, regardless of the climate. But you see what's happening here is these workers in these groups, while they have good access to their tools and a safe environment and can be very productive, they're working on one bathroom module at a time, and they move down to the next module as they go. And look how many teams are in there doing that. I mean, this is not even as good as Henry Ford's moving assembly lines from 100 years ago. We're not applying lean practices even without automation. So yes, we're creating these volumetric modules, and we're shipping a lot of air around the country. So the mixture of panelization and volumetric modular is important. And whether you're just doing workers indoors or whether you're doing automation is important. So let me just give the precast example around automation. Here's 2 different machines. The one on the right is spiraling out rebar to create columns. The one on the left is creating some beams. But you can see that they're working from these spools of rebar that are being fed into the machine. That's actually the limiting factor for these. So, you need to understand each station in a factory. Do they have kilns or not? And what's the size of component that can fit into the kiln? What's their tilting station like? Do they have essentially a 3D printer to lay down the concrete? Is it going onto a vibrating table to level it, or do they have to do a traditional process? In the back of the factory, are you seeing these coils of rebar that go into the machine or not? These rebar, if we get to this welding machine as an example that's fed by these coils, this can produce sheets of rebar very, very quickly. There's a machine after this that folds the rebar in certain ways. But you need to understand the limitations of the machine. If you get a gauge of rebar that's too big, it doesn't come on a coil and it can't work this machine. So actually next to this machine in this factory are a bunch of workers indoors hand tying big rebar that can't be fed through the machine. That could have been designed differently, understanding the limitation of rebar sizes. And likewise, the logistics could have been handled differently. I'm going to skip this for right now, but these are options about how MEP might be integrated into these systems. So let me go to the last 2 points here, which is what's the right mixture of volumetric modular and panelized modular, and how do you combine them together? And what is the content library that you create, and what knowledge are you capturing? Let's say that we're interested in 3 areas of knowledge. We're interested in logistics, we're interested in manufacturing capability, and we're interested in the placement on the job site. So perhaps the width of this double T is based on not just the bed on the truck, because you can go from 9 feet all the way out to 18 feet based on whether it's going to be an escorted vehicle or not. But maybe the limitation is by the sheet welder, and that's what sets this dimension. Maybe the thickness is going to be determined by the cranes, that you're going to use a mixture of mobile cranes and tower cranes. And with the mobile cranes, you can't lift as much. So you're going to leave exposed rebar in this design. That means you can put more of these on the truck, and you have 2 different lifting options when you get to the job site. So the thickness of the concrete and whether it's a full pour or half pour is based on lifting. And then finally, the truck bed size is what determines the length. And again, it's whether you want to have an escort and travel at limited times a day, or you want to have a vehicle that can deliver any time of day. So I'm going to pause here because I've jumped through the first 2 parts and ask Margie if you've been getting questions. I'm trying to be conscious of time because I probably have already gone over a little bit what I intended. You're muted, Margie. Margie, you need to unmute.
Hi, I'm sure the audience, like I am, have so many questions pouring in right now, but I just want to pull out a couple of them right now. Okay. So there's some questions in the chat box. I'm going to unmute people. If you could just say your name and where you're from and ask your questions. So first person I want to call on is Ashley A. So Ashley, I've unmuted you. If you want to just introduce yourself and ask your question to Patrick.
Hi, thank you, Margie. Can you hear me?
Yes, you're great.
So my question was around the design redundancy. What suggestions would you have for reducing redundancy in design?
Sure. This is not about software at all or technology at all. This is a business issue. And it starts with contracts. You have a best chance of reducing redundancy if you're in a design-build relationship, as one example, in which you're working for the general contractor, and therefore you have the protection that their insurance provides as opposed to the normal architectural malpractice sort of insurance. This means that potentially you can look at delivery issues and fabrication issues in conjunction with a contractor. That's one form of contract. I think another that even the GSA has experimented with is pre-qualifying subcontractors and fabricators. If we're talking about something like precast, these sheet welders, this equipment is commonly available in most precast factories these days. You just need to find 3 or 4 that have this kind of equipment. You're also going to see there's not that much difference. The sheet welder, as an example, rarely makes sheets bigger than 10 or 12 feet. They happen to be around 9 or 10 feet. They happen to be the same as a truck size. So making sure that you can make the product in multiple factories by having the owner pre-negotiate these relationships is really important. So it's really a contract issue. It's a relationship issue. And then finally, you can do it with different technologies, but technology is really the last issue.
That's great. I'm going to unmute, sorry, I just lost him here. Pete Dumont.
Yep.
Where's Pete?
Yeah, thanks, Margie.
There you are. Pete did a webinar for us a couple of months ago, so great to have you back. Go ahead.
Good to be back. I love this presentation. It resonates so strongly. And I guess a question would be, what is your view on compensation models and economic incentives? Because companies tend to drive almost 100% towards the economic incentives that are most lucrative for them as a business. And I think if we continue to compensate by the hour or these fairly traditional models we've always used, it will be hard to transform the economy of construction in the ways you're talking. For instance, moving toward a leasing economy, for instance.
Let me understand, is it compensation for a contractor or for an architect and an engineer?
All the above, buying materials, you think about leasing your elevator example, you can,
Sure.
instead of buying the elevator, you basically pay for it over the 20-year life of the facility, for instance. It's a completely different model of compensation for the supply chain. So I wanted just your perspectives on that.
I think a lot of this hinges on building product manufacturers. You look at Solar City as an example. We'll come put panels on your roof for free, and we'll just tap out of what you're paying PG&E or somebody. So that's what I expect to see with elevators and many other parts of the building going forward. Now, I think the model for architects and engineers and for subcontractors and general contractors are different. For architects and engineers, we have seen an erosion. Certainly, I've seen it in my 30 or 40 years in practice. In the 70s and 80s, when I would go on a job site, I was, had a lot of authority. And I was there as the owner's representative to be sure that construction was being managed properly and that the materials were in place and the work was done properly before it was paid for. Well, in the 80s, we suddenly got into fast track construction and construction managers came along, and suddenly 25% of what used to be in my fee dropped down to about 10%. I had to do the same job because of liability, but I had less money to do it for, and I had somebody else double checking what I was doing, which is sometimes helpful and sometimes not. Same thing has been happening for architecture firms in international work, where you're asked to do a detailed design development set, and there's an architect of record locally that's going to do the construction drawings. So a lot of the fee has gone offshore as well. So I see architects and engineers with the same liabilities they've always had, but an erosion of the revenue that they can generate. That's one kind of problem. And I think they need to begin to think about buildings, not as individual products, but we're in the healthcare industry, or we're in the education industry, or we're in the housing industry. And in that market, these are the products that I will need, and I need to develop those products with manufacturing companies. When I worked at Herman Miller, we had a long history of not assuming that our designers were the best designers. And we would go out to, Ray Eames or somebody like that to design a chair, or Mies van der Rohe to design a chair. We didn't assume that we were the best designers. We outsourced design. But there was a partnership and there were royalties involved. This is, I think, the future revenue path for architecture and engineering firms, is to have their intellectual property bound into products and that are branded around them. And they use, one of their preferred products on their own projects from time to time. With construction companies and subcontractors, I think it's quite a different proposition. I think it's about how you manage the supply chain differently. As a general contractor, you have to begin to bring some manufacturing in-house, and you have to have preferred manufacturing partners that you work with over and over. But I think it's also in the supply chain, in the way that you do your purchasing. By pre-committing to certain manufacturers, whether it's a facade system or an elevator, you're going to get a 20-25% discount by early commitment. That reduces the manufacturer's cost for marketing, for competing, it creates predictability for manufacturing for them. So I think it's logistics for construction people, and I think it's moving in intellectual property for architects and engineers. Does that answer your question, Pete?
Extremely well. Thank you.
Okay. I'm going to go back to presenting, if that's okay, Margie, because I don't want to run out of time.
Yep, we have more questions, so we can toggle back and forth.
Okay. So let me go to the last part, which is around design for manufacturing assembly. This is the process that, RIBA in UK or AIA in US has had for quite a long time. And it's, I joke that it's this perfect process that only moves forward, never backwards, that you're given a program at the beginning, and then the program is perfect from the outset, and you never have to change the program. And so you have a conceptual design and schematic design, you get a permit, and you move straight into design development, straight into construction drawings. And there's never any reason to actually go back and redesign anything. But that's sort of the mentality here. This is I ran an industrial design group at NBBJ, and I thought I understood it. But when I worked in manufacturing at Herman Miller, I really got to understand how different an architectural design process is from many other industries that have design processes. And I think industrial design is the biggest gap. Instead of having this sequential process in which the program is already perfectly defined, in industrial design, you have a concept that you're trying, what's called a brief. We would like to change the following behavior of our shoppers, and we want to have 3 design elements that cause a change in behavior. So it's anthropology in a way. You're studying behavior and you're watching how behavior might change. So there's industrial design, there's a user interface, user experience, there's research about the behavior as it is, and you're understanding what you're trying to achieve as a business, not as a product. Then you come up with prototypes, maybe 2 or 3 prototypes that may be able to change the way the business behaves, and you test them out and you say, this one seems really promising. But you think next, how will we make it? It should be plastic or metal, or should have these parts or those parts? Should we source some things? Should we do some things ourselves? How are we going to make this thing? And so you have a more mature prototype. Then you get into production design, which we never do in construction. We say, how will we leverage our factories, and how will we produce this, and in what volumes? And finally, we put all that together, and then we have a product. That's a very different process. And I think we need more industrial designers working with traditional construction people to rethink how we deliver off-site. If I look at modular buildings right now, this is probably sort of state of the art. This is a UK company, and they've analyzed a building and they've said, red and orange is bad and blue and green is good. We have a precast facade system. We think it's great. We can do that easily. We have these units that are modular volumetric units. It takes 3 of these modules to make one living space, like a 1-bedroom apartment. So blue, we can definitely do that. But orange, we would like another contractor to do excavations and foundations, maybe even the podium that has the parking, maybe even the core that has the elevators and stairs. Our profit margin is not that good there, so we want to split the contract. We would like some other construction company to do that skeleton of the building, and then we'll put all our modular products on top. It's a pretty good system. I think, Katerra's system is better because they've thought through some other issues. They have a mixture of panelization. They have a volumetric products like bathroom pods and panelized products together. There's a lot of focus on wood as opposed to different materials. But, you'll see several things like this. But I think it's really quite different than when we talk about modular and manufacturing. And this example is 15 or 20 years old. The new stuff we do with Volkswagen and Scania trucks and some other customers, I can't really show you yet. The new BMW products, they're very innovative. They're very clever. But here's the fundamentals from Peugeot Citroën from 15, 20 years ago. It's built around a platform. And I break the building or the product up into 3 elements. There are these fixed elements. In the case of a car, that's something to do with the chassis and something with the drive axle. Then there's these scalable elements. You can see it happening around the firewall. You can see it happening in the body on top and the compartment inside. And finally, there are these customized components in yellow, the bumpers, the sunroof, a few upgrades to the engine. But we want to produce 80% of a vehicle from fixed and scalable components. And just with this simple system, I can make a family van, I can make a hatchback, I can make a sports car, I can make a family coupe. I can make 5 or 6 different products from this one platform. They look very different. They don't look cookie cutter, but they are based on this principle. And the customized components, I actually get paid extra for it. So if somebody, FedEx comes in and said, we want to buy a whole bunch of trucks from you, and we want these big step bumpers, and we want larger mirrors, and we want this, that, and the other, fine. Those are all paid for upgrades. We're glad to do that for you. But the 80% that comes from the platform, that's modular. This is not volumetric boxes that are being shipped that fit on trucks. That's how construction people have often thought about modular. This is multiple integrated systems that fit together from a supply chain in a very precise way. It's a different way of thinking. And if you think that it, cars, oh, we're going to make 10,000 of them. Well, here's our customer, Maya Werft, who makes cruise ships. And these are produced in 18 months. So from the time, Carnival or one of the cruise lines comes in and orders, 16 to 18 months later, this ship is available in the port of choice with full crew trained, and all the food and linen and materials are in place. It's ready to take on passengers. It's large, it's complicated. It takes 3,000 to 4,000 people as guests. It has a crew of 2,000 to 3,000 people. It has, it's a floating 5-star hotel with movie theaters and sports facilities. It's as complex as any building is, but the way in which it's delivered is a manufactured process and has much more tight quality control and a much more predictable outcome. So that's a difference, I think, from industrial design thinking to architectural design thinking. So let's get to this last part about these production control systems, because I'm running out of time. What we need to do is create these solid models or fabrication level models and have a two-way connection between them and the BIM software that's used. And we need to get it onto a data platform, PLM, we call it Product Lifecycle Management Platform. In this data platform, we can preserve multiple file structure, the architect's preferred structure compared to the scheduler's structure, to the estimator's structure. And we do that with, in manufacturing, we call it an engineering bill of materials, EBOM, and a manufacturing bill of materials, MBOM. So I'm calling this construction bill of materials, CBOM. And from that, you want to create a work breakdown structure. And the work breakdown structure, then you can connect to labor, materials, scheduling issues, and you can connect it to cost issues. So now it's got 4 or 5 different data structures that are all preserved. So if in the scheduling portion you see you want to deliver the project differently and it's going to require some design changes, you can immediately inform, say, a Revit user back here of what has to change in the design. A data platform with two-way communication provides that. But we're working with file share systems and we're working with importing and exporting. We're not working with object databases and PLM platforms. And we're not having the model drive 50% or more of the building. We're having a bespoke custom design drive it. All of these are done in a way that's problematic today. The next 3 things that are critical is that you have to have a logistics plan for trucking, for laydown, for lifting. You have to optimize your factory because your factory makes money based on throughput, whereas the construction sites are cyclical. So you have to balance these 2 businesses in such a way that your logistics, your factory, and your site are balanced. And finally, you have to be able to create work instruction on the job site and an execution plan that you can monitor and adjust as you go. That's very different than what we do today. Here's an example of a project in London. I can come back to it in Q&A if you want to get into it in detail. And so what this looks like is, here's 2 different examples. This is a U.S. Olympics with McGrath doing the wall system. So we have a full-scale mock-up. We should continue to do that as a controlled sample. But we have a virtual mock-up that is parametric and can be adjusted as needs arise in the field. And then we laser scan the whole thing so we can see these diagonal braces and safety lines, but we can also see the placement of the steel and the facade elements as they go. So we know if there's an accumulated error and requires a change in manufacturing as materials arrive on site. So it's this balance between these things of logistics, the systems, the tools and equipment used to support systems in the field, and it's worker safety planning down to the, so you don't have this in Navisworks, you don't have it in Synchro or Vico, looking at individual workers and ergonomics, but that's the level you've got to get to, I think. So in the end, it looks something like this, where you've got a factory simulation that you're running, and if you need to make a change, you run a new simulation showing that change. If the change is acceptable, there's a script that actually sends the information straight to the equipment in the factory and it starts creating the new product. It's almost instantaneous. It's a change that can happen in less than an hour. And here's the on-site execution. I'm not going to run the animation on this one, but it's the same thing. We're looking at precision on the job site, precision in the factory, And between those things, we have a collaborative interface that lets everybody see how the thing is proceeding. So I've just hit my 1 hour limit. I hope people are prepared to stay on for more than just 1 hour, but I'm trying to stop on time, Margie.
I appreciate that. And I'm just going to start pulling some questions and unmuting some people to let people ask their questions. I think some people have had to leave because they've got, other appointments that are going right now. So let me see if I can pull out Eric Law and say, Eric, did you want to ask your question now?
Great presentation. My question is around contract.
Yeah.
We have a lot of clients that say, oh, I want to leverage prefab to shorten the schedule, and they're using a low bid contract method.
Yep.
And obviously they come to us with a design, and we have to tell them, well, it's too late, right?
Mm-hmm.
You made all the bad decisions up front. How do you have that conversation and get clients and teams to start thinking about DFMA and configuring projects?
So I work with some construction companies in Europe that have exactly this issue. They are pure construction. When I work with a company like Lend-Lease, they are the developer. They hire the architects and engineers. They are a contractor, and they are the operator of the asset after it's complete. They don't have the problem, but big construction companies do. And so what I'm increasingly hearing in Northern Europe in particular from these construction companies that have invested in manufacturing is they're starting to prioritize work in which they will be engaged at the very beginning of the design process. If they can't have influence on the architects and engineers at the beginning, it severely limits the innovation that can be provided in delivery. So if you're construction only, I think you've got to talk to owners about the advantage of design build, so that as soon as the architect is engaged, the construction company is also engaged. And then the second thing you have to talk about is, I understand you want to have a bid, but let's have a bid to pre-qualified manufacturers who have high quality off-site capabilities. We understand what their machines are and what they're capable of doing. We want to leverage them to the full extent that we can. It's still a competitive bid, but it's pre-qualified. I think from what I've seen over the past 30 years or more, that you never get the best price at the end of the day from the lowest bidders. You get the best price and the best value from a negotiated situation where you have reliable partners working together. And it's really hard to change the attitude of building owners. They still believe the myth that the low bid is going to get them the best value, and it's rarely true.
Question here from Zig Rubel, a board member for CIDCI. Zig, do you want to go ahead?
Hey,
Yeah.
Zig, how are you doing?
Good, yourself? Great presentation.
Yeah,
I
thanks.
think I could listen to this all day and night. So my question is, and I'm glad you used the word platform. So I think we all would agree that an API between Revit to Tekla to Archibus to all the other softwares is probably not going to create this platform.
Nope.
So my question is, will it take another industry player or software developer to come up with software that will help create the platform to enable this 2.0 or 3.0 or 4.0?
It already exists, and it's been available to manufacturing for about 15, 20 years. PTC has Windchill, its PLM system. Siemens has one. Dassault has one. There are many companies that have object database platforms that can handle geometry from multiple sources. So it's not that anything has to be invented. I think that this continuing myth of IFC solving things is problematic. I think that we all need independent third parties that have API access to software from more than one company. So we have a partner in Canada, for example, that has access to Autodesk API and our API. So they can create a connection between our tools that others can't create because you have to own both APIs to do it. So it's not the primary software vendor that's going to solve the problem. It's these intermediaries who have access to multiple APIs as step one, and then it's got to go to an object platform, a PLM platform, as step two. All of it exists. All of it can be done. It's more of a business problem. That's the reason it hasn't happened.
Okay, great. Thank you.
Sure.
Great. We have a question here from Eric Raff, a CIDCI board member, but he texted me that he had to go to another meeting, but I think his question's a good one, so I want to put it out there.
Sure.
He says, what is your expectation for how panelized systems such as, I've never pronounced it, but NEXI, I guess, will play in the movement towards offsite prefabrication? And the same question for mass timber and CLT.
Okay, so that's a
It's a big one.
Let me first separate the challenges between, let's just say, wood, steel, and concrete. In Canada and Australia, there's pretty good movement for CLT and timber-based systems, also in parts of Northern Europe. In the US, there's resistance about fire code and a bunch of things right now. So we're not able to move as quickly as we'd like. I think that these wood systems, because of carbon capture, because of the weight, because of the speed of delivery, because of the flexibility, ultimately will be very good systems. And they should be the primary panelized portions of the systems coming from wood products and CLT. I think we have underserved metal and overserved concrete historically. These light gauge metal framing systems, Nucor makes a machine. There's a number of machines. There's one out of Finland that's quite good. Their ability to take a roll of sheet metal and turn it into panelized or volumetric components is really quite impressive. The way that the machines will also mark all the instructions, that you don't have to look at the drawings anymore. The instructions are on the panels in multiple languages. The ability to integrate the electrical and other systems into metal is really quite good. So metal is a really great and flexible system and gives you terrific spans and performance. Concrete, I think, is a bit of a laggard, but for some reason in many parts of the world, most of the offsite and manufacture is a concrete type process. I see more promise with GFRC, or glass reinforced, glass fiber reinforced concrete. Those systems are lighter weight, better performing, and have less carbon problems, I guess, than traditional concrete. So I think we have to look at hybrid systems, and I think that a focus on just one system is problematic. I think that the decision for more panelization or more volumetric is based on the labor. If you think of a bathroom pod as a classic example, every trade goes in. You send in the framers, you send in the plumbers, you send in you have to put a fan in the roof. Ceiling says an HVAC guy. You've got the electrical guys, you've got tiling, you've got every trade going into a tiny space. So what that tells me is it's worth shipping the air. Katerra is one good example of this, where they have a nice product where the grab bars and the towel racks and the other pieces are all packaged and stored in the tub. So it's a kit of parts delivered to the job site that you unpack efficiently. So as the trades go in, they go in a very efficient way. That is worth shipping air. That's where volumetric makes sense. For most spaces, they should be panelized, and the difference between a roof system and a wall system and a floor system is significant. I don't have time to go into it, but you always have to have a mixture, and it's not one or the other, and it's not one material or another. I think in California, for example, we'll continue to see some form of concrete construction for parking garages on a podium and wood frame on top for 3-4 stories. It's good for a walk-up. It's good for seismic. It's good for a lot of things. I think we're going to see hybrid systems, and focusing on one system only, I think, is a risky proposition.
Wow, Patrick, you're amazing. Thank you so much for this amazing presentation. I've just, my head is spinning, and I'm sure it is for so many of our panelists, but I think it's time for us to end for now. I guess that's just what I want to say. I hope you'll come back and do another CIDCI webinar in the next few months or so, just so we can see what you're thinking about next.
This was the lightweight version that I do for the AIA. I have one I do for software developers and manufacturers that gets into a lot more detail in the DFMA portion. And I would skip the business issues and legacy issues and go straight to details on manufacturing. So if there's a group interested in that, I'm glad to dig a lot deeper.
We'll be talking.
Okay. Good.
Okay. All right. For everybody still with us, this concludes CIDCI's online salon. This session has been recorded and will be placed on the CIDCI website as soon as possible. Thanks to wonderful Charlie Dunn for saving us. Please also join us for a very special session hosted by Walter P. Moore entitled Implementing and Scaling Project-Based Innovation, 8 a.m. Pacific Time on December 3rd. Presenters include Eileen Fan, Timon Hazel, and Ryan Seckinger. Please sign up if you haven't already for the CIDCI mailing list by subscribing at cidci.org. Thanks for joining us. And as always, if you have thoughts or comments, please reach out to us at CIDCI's website at the Contact Us link. Special thanks to Monica Swissler for getting us set up this morning and Patrick for an amazing presentation. We'll have you back again to see what you're thinking about in a couple of months when hopefully we'll know who the president is.
Yeah.
Be safe, everyone, and see you soon. Thank you.
Bye-bye.